open up the part that we're going to use for our optimized design. What you can see on the screen is the internal drag our original assembly tab into the center of the screen and then position it using one of the direction arrows. So what we end up with are two displayed parts side by side. You can see that now the window base is literally the volume that our new design must reside within. So let's go through the process of setting up the topology optimization. So we start by activating the Topology Optimization tab in the Topology Optimization toolbar. We start by selecting the design space and then specifying the material. We then move on to looking at the optimization features, which in this case are the solid bodies that represent the bores in the pipework. Some of these have thickness and are also defined as either keep out areas, keep in areas, or shells. We're also able to manage load cases. In this case we only have the one load case, but it combines a number of different pressures on the individual bores within the part that's to be optimized. Finally, we can set up the parameters for the optimization run itself. Inside of here we can define the resolution. We run the optimization. The optimization consists of three specific stages: a rough initial pass followed by a refining pass, and you can see both being illustrated in the progress bar, and then finally there's a meshing stage, and this is where the optimization body is created. Notice that when we hide the optimization features, we're left with one single body based on CAE technology. Here you can see we can quickly look at the maximum displacement and maximum stress in our new component. As previously mentioned, so we activate our reverse engineering toolset, and inside of here we have a command that allows us to convert the facet body to a convergent body. You can see that we're working with a solid form as we section the body. You've already seen some of the new functionality that's going to be coming with NX12 with the use of multiple display parts. Take a look at here. There are two. We'll take a look at both. The first one we'll take a look at will be chamfer. The user interaction is straightforward. You just select points around the edge of the area that you want to transition. And when NX has enough information, it automatically completes the boundary and creates, in this case, the chamfered transition. This is a very flexible and powerful way of being able to modify a facet body directly. So let's take a look at the other transition type, the blend. In this case we're going to transition the intersection area where the two bores meet. Again, we simply select around the edge of the intersection and then let NX complete the transition. So again you see a very powerful way of working directly with facet bodies. And without convergent modeling technology, this would be very time consuming and difficult to achieve. Finally, let's take a look at two other enhancements that are coming with NX. So we activate the drag and drop between windows option, and then using the face selection filter we drag and drop one selected face from our original assembly into our new topology optimized component. We can now use this copied reference geometry to position some hole features we want to add. And bear in mind, this is facet geometry that we're adding these hole features to. So we selected the direction vector for the hole, we select the geometry that we want the hole to be subtracted from, and then we use the reference geometry to position the holes themselves. We will now hide the reference geometry so that we're only left with our facet body on the screen. And again, you can see the 4 hull features that have been added to the Convergent body. And if we look in the Part Navigator, you can see that they are physical features that we could go back in and edit, change the size, change the type of. This is unique capability and would be impossible to do without Convergent modeling technology. So let's just recap on what you've seen in this demonstration. You've seen how we've taken an existing assembly and using topology optimization,